In this video, we're going to look at solving a systems of equations by graphing. Solving a systems of equations is finding the POI, which is the coordinate at which two lines meet. By definition, a system of linear equations is a set of two or more related linear equations considered together. The solution must satisfy each equation in the system. And now I'll show three ways to graph. We're going to graph the same set of equations three different ways, using a table of values, the slope y-intercept form, and then the x and y intercepts. So the first method is a table of values. So we're going to find three coordinates that are on the line to graph. You only need two. I like to use three just to make sure I didn't make a wrong calculation. So I'm going to take my values for x and sub in to figure out what y is. So in the first case, it's 0. In the second case, it's 1. And in the third case, it's 2. So I'm just subbing in those values for x. Now I'll solve for y. In the first case, becomes 2. In the second case, y equals 0. In the third, y becomes negative 2. So I have 2, 0, and negative 2. And I think I've done my correct calculations because the values here are stepping out at the same rate. I'll switch colors now and look at the second equation. Again, I'll use 0, 1, and 2 for my x values and determine what y is. There are no fractions, so these are pretty safe values to use. So subbing in for x, I get 0 the first time. The second time, it's going to be 1. And the third, it's going to be 2. So solving, it becomes negative 2y equals 6. Divide both sides by negative 2. Always do the same thing to both sides of your equation. Y equals negative 3. In the second case, negative 2y equals 6 minus 1. I'm taking the 1 across. I'll tidy up the right-hand side. Again, divide both sides by negative 2. And y equals negative 2.5. In the third case, push the 2 across, it becomes negative. So I get negative 2y equals 4. Again, divide by negative 2. And y equals negative 2. Now this coordinate, I could graph it, but I won't be too accurate. Thankfully, I have two nice coordinates that I can use to graph my line. So back to the first one, and I'm just going to graph this out. So 0, 2, 1, 0, and then 2, negative 2. So I can see that my slope is down 1 over 2, so I'm going to make a series of small guide dots for myself as I draw my line. And I'm just going backwards when I'm going to the left. And I'm going to make sure that I draw my line all the way through my graph, from top to bottom. And because it's a line, you need arrows on both ends, otherwise it's a line segment. My second line, I've got 0, negative 3, and 2, negative 2. I can see that my slope is up 1 over 2, so again I'll make a series of guide little dots, going backwards as I go left. Draw my line all the way through. Add my arrows, and then my POI, my point of intersection, is 2, negative 2. So that's how you graph a systems of equation using a table of values. The next method will be using the slope y-intercept method, and the slope y-intercept, otherwise known as b. So in this case, we want both lines in y equals mx plus b form, and we're going to pick out b and m. So in our first equation, we have, sorry, I hit a wrong button there. Let me go back to my highlighter. That would be slope, and this would be b. So I have slope of -2, and I have b of +2. Slope is rise over run, so I'm going to insert the hidden 1, which is found under every whole number. My second equation is not in the proper format, so I'm going to move the x across to the other side and then divide each term by the same value, -2. The -2's cancel out and become 1, and I get y equals 1/2 x minus 3. Then b is -3, and m is 1/2. And I have my rise over my run. So to graph this now, I'm going to go alphabetically. B and then m. So b and then m. So my first equation, b is 2. So I'm going to plot it on the y-axis. Slope is down 2 over 1. Rise or fall, then always run to the right. So down 2, run to the right. Down 2, run to the right. And now you can see the pattern. So I'm going to give myself a series of guide dots so that I can draw a nice line. And remember to go all the way through your graph, adding arrows on both sides. My second equation, b is -3, so again alphabetical, b and then m. And my slope this time is 1/2, which is up 1 over 2, up 1 over 2. I can see my slope. I can give myself again a series of guide points so I can graph it nicely. Drawing all the way through, giving myself some arrows on the end. The point of intersection is exactly the same as the first graph, which is 2, -2. So now we've done exactly the same thing. We found the point of intersection is 2, -2. First a table of values, and then using the slope y-intercept, graphing alphabetically b and then m. The third way to graph is using the x and y intercepts. So in this concept, you have your two axes, your y and your x. The x-intercept is somewhere along your x line. You don't know what x is, but because it's on the x-axis, you know that y is 0. The opposite is true if you're looking at the y-intercept. You have no clue what y is, but you do know that x is 0. And so we're going to take that concept and apply it to our method. So the first thing I will do is find the x-intercept, and the second thing I'll do is find the y-intercept. The equation actually tells you what the y-intercept is, but I will prove it using the method. So sub in 0 for y, so you have 0 equals -2x plus 2. Bring the 2 across, it becomes negative. Divide both sides by -2 to isolate x. And you get 1 equals x. So your x-intercept equals 1. The coordinate would be 1, 0. On the y side, sub in 0 for x. So you're trying to find y. You know that the y-intercept is 2 because you can see it in the equation. But so it's going to be 2 times 0 plus 2. So y actually equals 2. So you proved it by subbing in 0. I'm going to graph that first this time. So my x-intercept is 1 and my y-intercept is 2. You only need 2 coordinates to draw a line. So I can see my slope is down 2 over 1. And again, a series of guide dots so I can draw my line. I always like to go to the right and then go backwards to the left. And then nicely connect the dots all the way through the graph, arrows on both sides. My second equation, I just have to manipulate a little bit, but I've already done the work. I did it over here. So I know that my equation is that. And now that I've said it, I realize I actually don't need to do that. I can just simply sub in, right? So sub in 0 for y. And that, I suppose, is one of the advantages of using the x and y intercepts. You can deal with the equation as is and sub in the zeros appropriately. So this is going to give you x equals 6. On the y side, you're going to sub in 0 for x. So now it's 0 minus 2y equals 6. Negative 2y equals 6. Divide both sides by negative 2, and y equals negative 3. X is 6 along the x-axis. Y is negative 3 along the y-axis. Now here these coordinates are pretty far apart, so you have to figure out what that slope is. So it's actually up 3, so the rise is 3, then you're running to the right 6. So that's your slope, but if you reduce that, that's 1 over 2. So I'm going to go up 1 over 2, up 1 over 2, and now I can see clearly what the pattern is, so give myself a series of guide dots so I can draw my nice line. Add my arrows, and then again my POI is 2, negative 2. So now we've proven that these 3 methods to graph 2 lines work, and you get the same result each and every time. The next step is to confirm that you've done the graph correctly. So we know that we're trying to check the coordinate 2, negative 2. So the POI is here. So we're trying to make sure that it actually belongs to both equations. We can see it visually, and now let us prove it mathematically with numbers. So I have a series of steps along the bottom here. You're going to check each original equation. No equal signs in a check. Solve each side separately so that ultimately you get a situation where you've proven that the left side equals the right side. So I'm going to separate out my original equation without the equal signs. So now I've got a left side and a right side. I'm going to sub in my values. Y is negative 2. X is positive 2. My left side is solved. My right side is almost complete. And now I've got the left side equaling the right side. So that checks. The second equation, same thing, sub in appropriately. X is 2, y is negative 2. This becomes 2 plus 4, which is 6. And again, the left side equals the right side. And that's how you check. So the POI is indeed 2, negative 2. This slide now has 3 separate examples of 3 systems of equations to be done in each of the 3 ways that I just showed you how to graph. Please pause the video, try it on your own, and see if you come up with the same solutions as I do. Okay, I'm now going to show you my solutions, and I'm going to go fairly quickly. So table of values, here's my system of equations, x and y, 3 separate coordinates. And I like to use 0, 1, and 2. You can do a lot of these things mentally, so I'm going to sub in 0 plus 4 is 4, 1 plus 4 is 5, 2 plus 4 is 6. Change colors and do exactly the same thing with the next equation, 0, 1, and 2. Some of you will probably want to do that to your equation just so it's nice and orderly for you. So 0 then will become 2, 1 will become 1, and 2 will become 0. Take those two sets of coordinates and graph them. So it's 0, 4, 1, 5, 2, 6, and you can see your slope is 1, so I'm going to do a series of coordinates backwards and forwards just to give myself a start, and then make a nice clean line all the way through my graph, adding arrows on both sides. My second line is 0, 2, 1, 1, 2, 0, and again a slope this time of -1. So I'm going to carefully draw my line through my grid boxes, forwards and now backwards. And you can see clearly now that the POI is -1, +3. So -1, +3 will be the value that you check with this pair of equations. The second method is the slope y-intercept method. For this one, you do need to manipulate your equations and put them into y equals mx plus b. First equation, once you've done it, will be -2x plus 3. And the second equation, once you've done it, will be y equals 1/2 x minus 7. So in this case, b is 3, m is -2. I'm going to put a 1 underneath it so that when I get to graphing it, it's -2/1. In the second equation, your slope is 1/2 and b is -7. So the graphing is fairly quick. B is 3, so there's m. Slope is down 2/1, down 2/1. Again, a series of guide dots, just so I can make a nice line backwards. And here we go. Here's my first line. My second line, b is -7. Slope is +1/2. So a series of guide coordinates, backwards, forwards. Draw my line. And this time, the POI is 4, -5. So that will be the coordinate that you check when you want to make sure that your system of equations has been graphed correctly. The x and y intercepts, the last graph, when you sub in 0 to find the x-intercept, you're going to find that x is going to equal 5. When you sub in 0 for x to figure out the y-intercept, you're going to find that y equals 5. In the second case, the x-intercept equals -4, and the y-intercept, which is already in the equation, is 2. So 5 and 5 is the first equation. It's +5, +5, and you can make your line, slope is going to be -1 all the way through, adding arrows to both sides. And in the second one, you've got x is -4, y is +2, So you can see that your slope is up 2 to the right 4. So 2 over 4. Reduce it, your slope is 1 over 2. So add a series of guide coordinates. So you can draw yourself a nice line, connect all the way through. And your POY this time is 2, 3. And now my last slide. So we have 3 separate points of intersection that we're going to check. So we have -1, 3. We have 4, -5. And we have 2, 3. I've made a little bit of a challenge here, or a game. Once you add up your balance numbers, let's see if we can agree on what I'm calling the magic number. I'll do a demo for the first equation so you can see what the method is. So separate out your first equation, no equal signs, sub in, tidy up the right-hand side, and the left side equals the right side, and the balance number is 3, and that is the value that goes in the box. So you'll continue on and do that 5 more times, add them together, and see if you get the magic number. I'll pause, and now I'm back, and I'm going to continue on finding my magic number. So separate out the equation, no equal sign, sub in. I always put my negative values in brackets. This becomes 2 plus 1, the double negative, and left side equals right side. In this case, that balance number is 3. It's not always the same, as we'll find out shortly. So here we go, checking my second set. 2x plus y minus 3 is 0. I think I'll do 2 at once here, and that's going to equal 14. Sub in, 4 is x, -5 is y. This becomes 8 minus 5 minus 3, which is 0. Left side equals right side. On the right equation, you've got 4 minus 2, again, negative value in brackets. So that's 4 plus 10, which is 14. Left side equals the right side. And my balance numbers are different this time, 0 and 14. Last set. Separate out your original equations, no equal sign. And again, I'll do them side by each at the same time. Subbing in, 2 plus 3 minus 5. That becomes 0. Left side equals right side. Over on this side, y equals 3. 1/2. 2 is the value of x. 1/2 of 2 is 1. You get 3. Left side equals the right side. So your final values are 0 and 3, which means my magic number is 3 plus 3 is 6, plus 14 is 20, plus 3 is 23. So if you got the same value as I did, you did it correctly. And if you didn't, either you made a mistake or I did. Thanks for listening. Bye for now.